Hey all, welcome back. So, as I have told in the previous session on Friday, that I'm going to start system verilog sessions along with verilog sessions also. So, since today is Monday, I'm going to upload system verilog sessions. Okay, on Monday, Tuesday, and Wednesday, I'm going to upload system verilog as well as on Thursday and Friday, I'm going to upload the remaining tutorials on verilog. Fine, but today we are going to have a quick review on what all we have discussed in the verilog up until now, and then we will be introducing the system verilog in today's class itself. Okay, so when coming to verilog, so we have discussed various topics in verilog, so we will just have a quick review on what all we have discussed in verilog, and what are the important things, what are the basics that you need to know, and all we are going to discuss today. So, you all know what is actually VLSA, right? So, I don't need to give an introduction on what is VLSA and all, since everyone know what is VLSA. Okay, so it is a very large scale integration where we will be designing, where we will be creating the chips. Okay, ICs, which are nothing but a combination of thousands of transistors. Okay, so we already know like advantages in VLSI technology, because based on these advantages only, based on the advancement in this VLSI technology only, today we are here, right? And then coming to, we also discussed about VLSI design flow. This is really important, because when you want to enter into the VLSI domain, you should know what is design flow of VLSI. Like when you know this design flow only, then only you can understand where can you go, like which what are the things you need to learn in order to enter into this VLSI domain. You will know when you know the design flow, how the working, how the IC chip that you are using is being created. Okay, so that creation is nothing but this design flow. Okay, so based on this design flow only, based on when we know how the creation is done, then we know in which category we are. Like creation here is categorized into two parts. Like when you are designing an IC chip or IC, okay, any circuit, okay, when you are designing something, basically any design is categorized into two parts in VLSI domain. One is front end and the second is back end. Okay, basically front end deals with all the coding thing, and the back end deals with everything like fabrication and development. Okay, so in order to enter into like front end provides these kinds of opportunities and back end provides this. Okay, if you want to know more about this, okay, I'll link the playlist that I have explained everything clearly. Okay, I'll link that playlist link in the description box. You can go there, check all the videos on verilog up until now that I have uploaded. Okay, so then, now if you are into coding and if you want to learn coding, then what are the languages you need to learn in front end? Okay, so basically you need to know two languages, okay, like verilog and system verilog. Basically, what I can say in simple form is, when you are going to design side, like when you want to design a circuit, okay, you need to know completely, like top to bottom, about verilog. Okay, and when you want to go to the verification side, okay, then you need to know everything about system verilog and universal verification methodology. But here the thing is, only when you know the verilog only you can understand system verilog. So that is why, okay, when you want to enter into front end, you basically need to know verilog, system verilog, and UVM. Okay, so this verilog and system verilog are called as HDLs, which are nothing but hardware description languages. Okay, hardware description language is nothing but, from the name itself you could say that you are describing the hardware in the text format. in a language. Okay, that means whatever you are going to write a code in the RTL, that is being converted into the hardware. Okay, so this is what hardware description language is, because once the chip is being created, it can't again be recreated. That means once we create the chip again, we can't do any mismatches. If there is any mismatch or something, we can't do any modifications on the chip that we have already designed. Okay, and the chip creation really takes a lot of your time, as well as expenses also is very more. So that is why, since there is no way for modification during after the chip is being created, so that is why, in order to avoid that thing, we have created this HDLs. HDLs is nothing but, before making the chip, before making the IC, we will be first designing it in the form of language, in the form of software, and then we'll be checking it, and then we will send it to the backend where the actual fabrication is being done. Right, so this is about HDL. HDL is hardware description language. In simple form, it is nothing but hardware is described in a text format. Clear? So there are many advantages of HDLs. Okay, like reusability, flexibility, okay, low cost, because we don't need anything, just like some softwares and all. Okay, so that is why it is of low cost, and also the better simulation purposes. We are These are some of the advantages of HDLs. So now, one of the HDL that we need to learn is verilog HDL. Okay, we need to learn verilog as well as system verilog. Both are HDLs. Okay, so when coming to Verilog, it is really similar to C language. Okay, if you are familiar with C, you can easily understand Verilog. But it doesn't mean that if you don't know C, you can't learn Verilog language. Okay, because it is easier to understand. Like compared to VHDL and all. Okay, VHDL is also HDL, but compared to Verilog, Verilog is very easy to understand, right? So, and then when we go into the verilog HDLs, we have discussed about various topics in verilog HDL. Okay, as I told you that I link the description box, so I link the playlist in the description box, like verilog HDL tutorial, where I have uploaded everything that I am going to discuss as a basic today. Okay, I have discussed in deep about everything in that particular tutorial. You can go check it out there. Fine. So we have discussed about various lexical tokens. So lexical tokens are nothing but, okay, they seem very simple. Like when anyone asks you, okay, what is the operator, what is the comment, you can easily see it. But the thing is, even though they seem to be simple, they are the foundation. Okay, they are the basics. Without these lexical tokens are nothing but they are just syntaxes. Okay, if you don't know the syntax, if you don't have the foundation on syntax, how are you going to write the code? Okay, even though the syntax is just a basic thing, but without that basics, you can't go to the further code. Okay, how much big code you are going to write, you need to know the basics of that code, like how to write this, how to write that. Okay, sometimes the bugs may be very small, but even that small bugs will be stop your will be corrupt, like it will be corrupting your simulation. Okay, so that is why lexical tokens are important. So in this lexical tokens topic, we have discussed like various lexical tokens like white space, comment, operator, number, string, identifier, keyword, everything. Okay, so then one of the most important topic after lexical tokens that we have discussed is like data types. Okay, in Verilog we are having lots of data types. Okay, one of the important topics in Verilog, and in data types, the two major data types you need to learn is like nets and registers. Okay, these are the very two important data types in verilog. Okay, nets and registers. So net is nothing but we will be declaring it with a keyword called wire. Okay, just like in hardware, what does the wire do? It is just used for connection purpose, is it or not? In order to connect two components, you will be using a wire as a in hardware. Similarly, in software also, that is the work of the wire. So in order to connect, like in order to connect inputs or in order to connect outputs, in order to connect some intermediate things, okay, in order to connect some intermediate components, you will be using the data type called wire. And coming to the default value of this wire, it is Z. Okay, today I'm not going to discuss more about this because, as I already told you, I have discussed in detail about all these topics in my HDL tutorial. You can go there and check them out. Okay, and then we have discussed some examples also. Okay, then coming to ridge. Okay, so now coming to register data type. Okay, one of the major difference between this is also one of the important data type in verilog, but you need to know the difference between net and ridge here. Okay, so net is nothing but wire. Okay, register is nothing but ridge. Okay, so in verilog, net is used to drive the values. That means it's just a connection. So what does the connection do? It will drive the values from one place to another place, like one port to another port, one component to another component. So net is used to drive the values. And when coming to rich data type, it is used to hold the value. That means whenever you are giving any value to net, it doesn't hold the value, it will just pass the value from one component to other component. But when you want that value to be holded, okay, that means when you want to store that value for some particular period of time, then you have to use a data type called range. Okay, so this is the major difference between net and ridge, right? So net is used to drive the value, ridge is used to hold the value, and the default value of ridge is x. Okay, so, and there are many other data types like integer, real time, etc. Okay, and then the next topic is representation. Okay, that means when you want to represent variable, okay, when you are representing a value or anything, how are you going to represent it? Any variable or anything. Okay, so again, when it comes to representation, it is of categorized into two types, like scalar, vector. That means when you want to use only single bit, then you can go for scalar representation. And when you want to increase the magnitude of the variable, okay, for example, when you are going to design a just a not gate. Okay, so when it comes to not gate, it just have only one bit value like a, and it is. But when you are going to design some AND gate or gates, then it needs some multiple values, like for example, if you are going to design 3-bit AND gate, that means you need 3 bits. But when you use scalar, you will get only 1 bit. So in order to increase the magnitude of that scalar, you will be using the vector representation. Okay, in vector you will be having like specifications like MSB, LSB, which is nothing but most significant bit and least significant bit. Okay, these also you can see in the like in the long length videos. Okay, and then coming to verilog arrays, this is also very important. Okay, very important topic. Like arrays is nothing but ordered list of variables. That means when you want to store the variables which are of same category, okay, then you will be using this verilog arrays. Okay, so these arrays can be of any data type like net, range, integer, real, any data type you can have this arrays. Okay, and also we can have multi-dimensional arrays. But the important question that arises here is, okay, if you see the representation of arrays and vectors, they seem to be similar. Okay, they have some difference, but when you see at that particular time, they you will get confused, like which is array representation and which is vector representation. Okay, So that also I have explained in that my particular sessions. You can go check it out. So when it comes to arrays and vectors, basically a vector is a single element, like it is just a single element which is of n bits wide. Okay, that means, for example, if you see here, okay, so if you see here, okay, I'll just give you a small trick for this. So whenever you are using the variable, okay, whenever the representation is after the variable, then it is counted as array. Okay, whenever the representation is before the variable, then it is counted as vector representation. Okay, you can go check my full length video for this particular array versus vectors, and then we have seen some examples also. Finally, coming to writing the code. Okay, then we have started how to write a code by using modules. Okay, in verilog, module is very important. It is just, we will consider that as a basic building block. Okay, so building block, that means what does the module contain, everything we have seen that. And then coming to one more important thing, which is instantiation, because instantiation is must, because we will be connecting the RTL code with test bench by using this instantiation topic only. So that is why module instantiation is very important. Instantiation in simple words is nothing but creating a copy for the original module. That's it. Okay, so I don't want to explain much about this. Okay, so this is instantiation is nothing but creating a copy for the original thing. That's it. Instances means copies of original module. Okay, so I have also discussed various examples on this instantiation, and then coming to ports. So basically in Verilog we are having like three types of ports: input, output, and inout. And we have also seen how we are going to mention, like how we are going to write these ports in different styles in Verilog. And then we have also seen like port connection rules. Okay, right? And here the input port cannot be considered as rich. Okay, input or input ports can't be considered as rich register data type. So why is it? Because basically when it comes to input, what happens, input needs to drive the value to one component from one component to another, is it or not? In order to get the output, inputs need to drive the values. So in verilog, which is the data type that will drive the value? It is not the rich, it is wire. So that is why basically inputs and inputs are basically considered as wire. When it comes to output, it needs to hold the value. So that is why output is considered as rich. Okay, so we have also seen how we are going to map the ports, like when you are mapping is nothing but connecting. Okay, when you are writing a code in test bench, and when you are going to connect the RTL to the test bench, this connection is called mapping. Okay, so mapping is really important. And also in for port mapping we are having like two kinds, like two ways in order to map the port. Okay, like port mapping by order and port mapping by name. Okay, we have also seen that clearly there. And then coming to, okay, now we have written like RTL code. We have seen RTL code. What does the RTL code need? Nothing but module, ports, and then the actual code, like the actual logic that for example, if you want to design a full adder, then logic of the full adder, that's it. So that is the RTL code. Now coming to test bench code. Okay, so we have seen like what is test bench and what is test bench importance in verilog and all. Okay, so test bench is basically nothing but the place where we are going to test. Okay, the environment where we are going to test the circuit that we have designed. Okay, now how are we going to test the circuit? By passing the values into that. For example, I am designing the full adder. By passing some values into that full adder, and the full adder is giving the output that I want, so now my particular circuit is designed correctly. So that is what we need, right? So this verification in test bench, what we basically do, we will just pass the values. So before passing the values, first what should we do? Okay, we are verifying it, but we need to make the test bench clear that what we are verifying it, how we are going to confirm the test bench that I'm verifying this particular adder or particular thing and all. How are we going to do it? By connecting my RTL to the test bench. Okay, so this connection is varying in case of verilog as well as in system verilog, because basically in verilog it is very simple. Just we will be writing the RTL code and we'll be writing the test bench code, and we'll just use the DOT instantiation in order to connect it. Simple. But this is entirely different in case of system verilog. Okay, this is where the major difference occurs. That is why I have already told you that system verilog is hardware verification language. Why? Because verification is not as simple as we think. Is it or not? Because we are not learning these courses like verilog and system verilog in order to design like simple circuits like adder, subtractor, or else like that. Is it or not? We are going to design some huge circuits, or we are going to design some very complicated uh, circuits on this. Is it or not? So for that complexity, that won't end with such a simple concepts that we are thinking. So actually this is one of the major difference. Like in test bench, the test bench that we are writing in verilog is entirely different from the test bench code that we write in system verilog. Okay, so as for verilog, we have seen how we are going to write the test bench code and all. And then coming to, okay, we have seen like how are we going to write the code, how are we going to write the test bench. Fine. Now coming to code, RTL code. So we are having in verilog like different levels of we can say that different abstraction levels in order to write this verilog code. Abstraction levels is nothing but different coding styles, like we have discussed about behavioral, data flow, gate level, switch level. But I didn't discuss about switch level because basically switch level is ejected from verilog, we can say that. Okay, because basically in verilog we don't be discussing about the switch level, because we will be starting from gate level in case of verilog. Okay, so basically gate level, data flow, and behavioral. Fine. Okay, so in gate level, from the name itself we could say we will be writing the code based on the gates. Okay, just by seeing the structure of the code we will be just by seeing the structure of the circuit we will be writing the code in case of gate level modeling. Okay, so as I already told you, in gate level you will be using certain gates. Okay, and the syntaxes of that gates I have already explained all this in the full length video, so you can go check it out there. And then I also explained, like if you see here, you'll be using like whatever gates with along with some syntaxes they. And again, while you are writing, while you are connecting the gates and all, while you are writing the code, you need to follow the syntaxes that I have given here, that I have already explained in the full length video. See, okay, so this is about gate level modeling. Gate level modeling is nothing but the code in the gate level modeling is written by using the structure. That is why we call it as structural modeling also, gate level or structural level, because by seeing the structure is nothing but the logic diagram. Okay, by seeing the structure of this code you will be writing your, by seeing the structure of this circuit you will be writing your code. That's it. You don't need anything for gate level modeling. What you just need is the structure of your design. That's it. When you see the structure you can write the code. But here when it comes to structural level, so it is not always easy. For example, if you are designing some big circuits, okay, so it is not always easy to write a code by using the structure and gates, because the code will become lengthy. That's it. It is not always easy means, because basically why is it like that means the code will become lengthy. So everything, when we come to verilog, any language is generally, what we prefer is to reduce the lines of the code as much as we can, because when we reduce the code only, then the simulation takes place very easily. Okay, when you are writing some 100 lines of code, when the code will be simulated and when will you get the output? Is it or not? So our aim is to write the code as simple as possible, which is why we have switched from gate level modeling to the data flow modeling. So in data flow modeling, we will be writing the code based on the data that is flowing between the registers. That's it. Okay, so here what we are doing, we are writing a code based on operators. Okay, we have discussed about various operators in verilog, like arithmetic, logical, equality, relational, bitwise, conditional. Here all the operators are really important, because when you are going for any interview or when you are going for any written test in verilog, there won't be any written test without asking at least one of the operators. Okay, so that is why without at least asking one of the operators question, there won't be any interview or there won't be any we can say that returns test. So that is why verilog operators are very important. Okay, in data flow modeling we will be using the verilog operators, and this data flow modeling is called a continuous assignment. Okay, in data flow modeling we will be doing continuous assignment. Okay, what I mean is, that means by using the assign keyword, continuous assignment means we will be assigning it continuously, assigning the values continuously by using these operators. And we have also discussed some rules and regulations for writing these continuous assignments. Okay, and also discussed about delays in continuous assignment, nothing but delays in data flow modeling. Here in data flow modeling we are having again like three kinds of delays, like regular assignment delay, implicit continuous assignment delay, and net declaration delay. I have explained this clearly in the full length video, right? We have seen like various types of delays. And then after data flow modeling, then comes the behavioral level modeling. So basically in verilog we can say that behavioral level modeling is the highest level of abstraction. So why do we call it like that? Means, so when you are going to design a circuit, okay, in the starting, if you see, I have told the when you see the design flow, okay, VLSI design flow. So there in the starting is specifications. That means when you enter into any real time field, basically this specification is nothing but it contains all the information about the circuit that you are going to design. Okay, so the customer who wants to design, who wants circuit, so what he will do, he will be designing the specifications. Based on that specifications you will be designing the circuit. Okay, so they at the starting for anyone, the anyone in the real field, this specification is given as their thing. Okay, so when it comes to specifications, what it will have, as I already told you, for example, if I want to design an adder, okay, so what are the requirements for my adder? Okay, if I want to design some 4-bit full adder, so I need to have 4 bits. Okay, like 4 inputs, some sum and carry. So all these things I need to have, is it or not? So these are my, so I these are my requirements. So when it comes to the requirements, okay, so when it starts at that stage, like when I have seen the requirements, I don't have anything in my mind, like I don't have how the data is flowing or how the thing is being done or else anything. I just know how the circuit is behaving, is it or not, right? As soon as I see the specification, I'll get the idea. Okay, this circuit should behave like this. That means if I am giving this input, it should give that output. I am giving this input, it should give this output. So this is what I need. I will have the idea. So basically, based on this idea only, I'll be writing the code. Is it or not? So that is why when it comes to why, because why is it called highest level abstraction? Means basically in the real time mostly you will be writing any code based on this behavioral level modeling only. So why, the reason I have told you just now, because as soon as you have seen the step, you don't go to the lowest level like gate level. Okay, after designing, after receiving the spec, okay, then you just don't think like how many gates should this have, how many. Okay, you don't go to that level. is it or not? So that is why behavior level modeling is the highest level of abstraction. So the basic things in this behavioral modeling are nothing but initial and always blocks. Okay, we have also discussed about this initial and always blocks, along with how we are going to design a clock. And also we need to know one of the most important thing in initial as well as always block is, so one of the major difference between initial and always block is initial is non synthesizable, whereas always block is synthesizable. Okay, and also initial is executed only once, but always will be executed many number of times. Okay, there are many other differences, I have already explained that thing. And then coming to always block, you will be having the sensitivity list, which is nothing but based on the sensitivity list only the always block will be triggered. Okay, so we have also discussed about the importance of the sensitivity list. And then coming to assignments. Okay, in the assignments you are having like three kinds of assignments in verilog: continuous assignment, procedural assignment, procedural continuous assignment. Okay, I'll say it very simply. Okay, like in small three words, I'll small three sentences, I'll just complete about these assignments, just a basic idea. Okay, continuous assignment means here you are assigning it continuously, and also in continuous assignment whatever the execution is done, that will be done sequentially, that means one after another. Okay, when it comes to procedural assignments, in case of procedural assignments all the things are done, like we can say that parallelly. Okay, here in continuous as the assignment will be done at the same time after the execution of the LHS operation, whereas in procedural the assignment will take some time. Okay, and also one important thing is all continuous statements will be executed in the active region, whereas procedural statements will be executed in the in some of the procedural statements like non-blocking assignments, they will be executed in the NBA region. Okay, and when coming to, if you want to use both the things like continuous assignment and procedural assignment, we will be going for procedural continuous assignments. Okay, in this procedural assignments again it is categorized into two types like blocking and non-blocking. We have discussed clearly about what is blocking and what is non-blocking. Okay, you can go check it out there. Okay, so basically one great difference between blocking and non-blocking is blocking is executed sequentially, non-blocking is executed parallelly. Okay, in blocking statements as soon as there is any change in LHS expression, there will be change in the RHS expression. But in non-blocking statement, even though there is any change in the RHS expression, the LHS expression won't be changed immediately. Okay, it will take some time before changing it to the next value, right? So and then we have discussed about delays in assignment. Okay, like we are having again in behavioral modeling, we are having two types of assignments like delayed assignment and intra assignment delay. Okay, and then coming to one of the major problems in blocking assignments is race around condition. I have also made a separate video on this race around condition with examples, can go check it out there. Okay, so this is all about blocking and non-blocking statements. And then comes to in what I can say, like in gate level modeling, we'll be writing with gates. In data flow, we'll be using operators to write a code. So in this behavioral modeling, you will be using conditional statements, okay, which are like if else and case statements, and loops like for loop, while loop, forever loop, okay, always loop. And then so this is all that we have discussed until now, and there are like four more really important topics in verilog. Like one is functions and tasks, and the second one is compiler directives, okay, time functions, right? And then coming to randomization functions. Okay, like you're having very limited randomization functions in case of verilog, like dollar random and dollar u random range. Okay, so and some simulation control system task, we have already discussed about this while we are explaining about some of the codes, right? And then some regions, like in verilog you're having like four regions: active, inactive, Okay, non-blocking and postponed region, right? So now, since we have gave a quick review on what is verilog, now we are going to see, after having all these concepts in verilog, why verilog is not used for verification purpose. Okay, so there are many reasons for this, because the first important thing that I want to discuss is, if you see every concept in verilog, okay, you can see that verilog in verilog you will be writing the code in modules, is it or not? So from this you can say that verilog is module based. Okay, so when coming to modules, they are static in nature, so that is why. But when it comes to verification, the static modules are not used. Why? Because they are static in nature, so that is why they are not very easy. It is not very easy to verify by using the modules. Okay, so that is why, okay, one of the important thing is, since verilog is module based and we can't use the modules, like why is it? Because there is no way in order to write these components and combine them. Okay, you will see what is this writing and combining them and all once you know about the system verilog deeply. Okay, so as of now, since verilog is module based and modules are static in nature, we can't use the verilog for verification. One of the main reason is that. And in order to avoid this, like in order to avoid this static nature, we have come with a very advanced version in case of system verilog, which is oops concept, nothing but object oriented nature. Okay, okay, which is nothing but we will be writing any code in system verilog class based. Okay, when it comes to object oriented nature, we will be writing every code on class based. So classes are dynamic in nature, which makes them easy in order to uh, verify any design, any circuit. Okay, so this is the second reason, right? So, and there are very, like if you see, yeah, and one more important thing in case of one more another big problem in case of verilog is the regions. Just now we have seen that verilog contains four regions, like active, inactive, okay, like NBA and postponed. So whatever you're going to write, whatever you're going to write in RTL code or else in test bench, what you need to do is everything that you are writing within the RTL and test bench using Verilog will be running only on this four regions. Is it or not? Any code or any function or any task, anything that you are implementing in Verilog on RTL and test bench will be running in this four regions itself. So when there are only limited regions, what is happening is the race around condition occurs. Okay, we'll see it like how the race around condition. So in order to avoid that race around condition, we have come to the system verilog. So in system verilog, you are along with these four regions, like along with these four event semantics, we are having like another 8 semantics, so totally 12 regions in system verilog. So when the thing, like when the number of regions increases, so the clashes between them will be reduced. Is it or not? The clashes is nothing but the race around condition. Is it or not? So in order to avoid that, we have come to system verilog. And also, one of the important concept that was introduced in system verilog was assertions. Okay, assertions, you will be learning it once you enter deep into the topic. So assertions is nothing but they are very essential part of verification. So these are used in order to know the behavior of the design. In order to verify the behavior of the design, you will be using these assertions. Okay, and then, okay, so like they are in many more. And also when it comes to Verilog, you will be using only like wire rich data types. But in system Verilog, you are having many more data types along with, like along with wire and rich, you are having many more data types. Okay, so these are some of the disadvantages in verilog which has led to the evolution of system verilog. Okay, so some of the system verilog features, very important features, which made the system verilog more advanced compared to that of verilog, like randomization, improved data types, synchronization. Synchronization is nothing but synchronizing means from the name itself, like synchronizing means the RTL and test bench, the working of RTL and test bench together, that is called synchronization. So in verilog, this synchronization, because that is what I told, since it is having only four regions for executing all the things in that we are writing in the verilog, so this synchronization sometimes mismatches, which leads to the errors in the program, like which leads to errors in execution. Okay, so this synchronization very lot improved in system verilog. And like as I already told you, assertions in order to know the behavior of the circuit, functional coverage, this is also very important, we'll be discussing it further. Okay, and then one of the best important topics is oops nothing but object oriented programming. Okay, so this is about review on verilog and um, why, even though we are having verilog, why we have come to the system verilog, and what are the some of the advantages in system verilog we have seen in this video. Okay, so in the next video we will be discussing about system verilog advantages, and also what are the, as I told you, there are many advantages, we'll be seeing many more things in the next video, right? So that is all for today. If you like my explanation, please consider subscribing my channel and hit on the notification bell also. Thank you. If you come under any VLSA aspirants or those who are interested in VLSA domain also, please share this video for them so that it could be useful for them.